Now I'd like to introduce our next panel before lunch, and we'll get into one of the areas where we've had a lot of conversation and interest in what are some of the actual applications of autonomous trucking and what are some of the potential applications of autonomous trucking and some of the economic sectors that are most prominent in North Dakota and the Northern Plains, including agriculture, energy, and some other related rural industries. So I'd like to introduce our panelists and ask them to join me on the podium now. And that's Kevin Siegel of Kodiak Robotics, who was introduced yesterday and you got a chance to talk with at the networking reception. And Maynard Factor of Kratos Defense. And you haven't had a chance to meet Maynard yet, and so Maynard is the Vice President of Business Development for Kratos. He leads global sales, marketing, and new business development, while also guiding long-term strategic planning, product development, and internal research and development initiatives. He has deep expertise in driverless vehicles, ground robotics, and unmanned systems, and he's played a key role in advancing Kratos AV efforts across the military and commercial markets. So Maynard, I'd like to introduce you first, and I believe you have a presentation.
Yeah, good morning, everybody. Can you tell I wrote that job description? Appreciate the time, appreciate the opportunity here to chat with everybody about some of the different deployments that we have underway, some of them right here in North Dakota. As Denver mentioned, I'm with Kratos Defense, and Kratos Defense is, we're sort of a national security focused technology and products company. So while we focus on developing technology for the defense industry, we also develop technology for national security adjacent industries, such as the ag industry and infrastructure. And Kratos is about a 4,000 employee company. We do about $1 billion in gross annual revenue. We have different divisions within the umbrella, some focused on missile defense, rocket systems. We've got a C5ISR group, we've got a microelectronics group, and then the group that I reside in is the Unmanned Systems Division, the Unmanned Systems Group. And we develop all kinds of really cool things, to include some airplanes. We make the airplane in the picture there that you see is the Valkyrie. That's an airplane that's about the size of an F-16, and it's designed from the ground up as a pilotless aircraft. We've actually done some test flights here in Grand Forks, I think it was last year. And so we use that with the military. It flies in formation with F-22, F-35. It deploys small drones, it can deploy weapon systems, and does all kinds of really cool things. We also develop driverless technology for the military, so we've automated a variety of different vehicles. And where that's important is that the technology that we're developing for the military, we are then able to adapt it as sort of a dual-use technology into commercial spaces to address different challenges the industry is faced with. So our goal here with driverless technology, specifically in the commercial space, is to bring real solutions to different industries that can use the technology safely. And we adapt field-proven technologies, so technologies that we developed with the military, and that we've also developed in collaboration with departments of transportation and different roadway authorities. We are taking technology that is available today. It's more leading-edge technology versus bleeding-edge technology, and I'll walk into a little of that in a minute on how we deploy our driverless tech, which is a little different from some of the other folks that have been up earlier this week. So where we're trying to address is we're trying to increase safety for some of our clients in the infrastructure, for example, infrastructure industries, and then in supply chain industries, we are addressing the impacts of driver shortage, so enabling business continuity. And here's just a quick picture. I'll walk into a few of these, but the different driverless self-driving systems that we have deployed in the defense space. We originally started deploying tech for the military to reduce warfighter exposure to dangerous missions. So if you can imagine a route clearance mission, for example, where somebody would have to be in a vehicle and look for roadside hazards, we can now automate those vehicles so the person can remain within a safe distance to any kind of hazard like that, and automate the vehicle to move it forward and do what it does best. And then from there, we started automating vehicles for infrastructure, mobile maintenance operations, where there's different scenarios where operators have to literally get behind the wheel of a mobile crash barrier, which is called a truck-mounted attenuator vehicle. I'll talk a little bit about that. And then moving forward, that's what aligned us to get into the Class 8 tractor trailers and deploying different trucks within the ag space. So what our goal here is what we're providing to our clients is we're providing them an opportunity to increase the efficiencies with their different deployments, increase safety, reduce costs, so costs associated with putting vehicles on the road and the liabilities associated with that. So it all aligns with increased safety, efficiency, maintaining business continuity. So when you don't have enough drivers available to drive to, let's say, haul ag products, for example, they can turn on the automated system and run the vehicles without a driver. So the way we deploy the technology, like I said, is a little different from some of the other folks. We deploy the trucks in a two-vehicle configuration in what we call a platoon or leader-follower configuration. So the way that works is we retrofit the trucks with the automated tech. So I start with my client's existing fleet vehicles, whether it's tractor trailers, TMA vehicles, or whatever. And so we put our own computers, our own navigation systems, our own communication systems in there. And the lead truck is a human-driven truck. And as the driver drives that truck along the route, it's actually transmitting high-definition map data, real-time, pretty near real-time map data to the driverless follower. So you have this follow the leader scenario, which is very cool in a lot of ways, and works very well for our clients in that it offers deployment flexibility in that we don't have to do a lot of route planning for our vehicles. So the lead driver simply drives the route that they're going. If there's a detour for whatever reason and they need to go a different way, they simply go a different way, and the map data is continuously transmitted to the follower, and the follower follows the leader. Also with platooning, our clients, and more importantly, their drivers that are existing drivers within their fleet, see the technology as non-threatening to their job. And the reason is that they are still needed to operate the lead vehicle, and they're incentivized to operate the lead vehicle because when they pair the driverless vehicle with their vehicle, they're paid more. They're incentivized to make, for example, in the supply chain, they're doing 2 hauls. So there's a lot of advantages there to them, and they're a key decision maker as part of the deployment of the tech, right? So they can adapt their driving behavior to whatever conditions are on the roadway. So we address some of the challenges with a human decision maker versus having to rely very heavily on sensors and AI and machine learning and that sort of thing. So there's a lot of advantages there with platooning that make it a little easier to address the challenges that our industry clients are facing, that they see the driverless tech as a solution for. So as I mentioned, we do bolt on the technology onto the vehicles. We add the computers and all the different things. That's an advantage to our clients as well because most of them have large fleets of trucks and they have processes and procedures for maintaining these vehicles, and they don't want to have to change the vehicles to accommodate the technology. So we come in, we bolt the kits on, we provide the teams a very comprehensive training program, which currently we do that in Florida. And for whatever reason, it seems to be perfect timing in the winter for North Dakota system operators to come down to Florida to learn how to operate the system. So it works out really well for everybody. But yeah, we're running through a month-long training program. We take them out on closed roads. We get them familiar with operating the trucks, and then we work them through low-volume roadways and then up to interstate deployments. So just to kind of walk through a few of the different deployments, there's a lot of slides here, so I'm just going to do it real quick. We already talked about the defense stuff that we do. The ATMA is what we call the autonomous truck-mounted attenuator. This is one of our first commercial deployments. So we worked very closely with Department of Transportation to develop out the tech such that the teams that do mobile maintenance operations. So for example, when you see these maintenance trucks putting stripes on the road or they're doing patching or crack sealing, they have this crash itinerary vehicle that follows behind them, and it provides a layer of safety for the workers and equipment from the traveling public possibly entering the work zone. Very dangerous for somebody to drive this vehicle, so a great adaptation of the tech is to take the person out of that truck and move them to a different location in the work zone. So we have 18 systems, 18 of these deployed across the United States. We work, like I said, with all the different state DOTs. We are running these systems driverless, so we have a driverless follower in certain states. Colorado has 3 of them that are running driverless. California is also, and Oklahoma, I believe, is the other state that's running driverless. So it's cool, and it's taking off very well. And it's because it is a critical safety system. Nobody can deny that removing a human from a vehicle designed to be, hit is a bad idea. The deployment that we have currently getting ready to get underway again in North Dakota is running in Wahpeton, which is about an hour south of Fargo, and we're hauling sugar beets. We're running back and forth between satellite piling locations and the granulated sugar processing plant. We're teamed with Mindak Farmers Cooperative on that. We did some previous deployments the past couple of seasons, and everything went really well. We've got some new tech that we're putting on the trucks, and we're going to be collecting a lot of data to present some different information to the stakeholders involved in that program. But everything's going really well, and it's super exciting. And no matter how much we tried to keep it under the wraps, the folks in Wahpeton, they have figured it out. It's like, I think population 600 or so people. They struggle with finding enough drivers to run these trucks, so that's really the motivator for putting the system on the road. Another deployment that we had underway is on the Minnesota side, where we were hauling soybean oil and tanker trucks, and we're running back and forth between 2 different phases of the refinement from soybean oil to biodiesel. So that's a unique deployment. I don't know that there was anyone else that's running tankers. We were the first to get approved platooning plans in North Dakota, as well as also in Minnesota, to run these trucks. So we're getting some really cool data. And as you can imagine, running trucks up here in the Midwest and the northern part of the country, we are challenged with some severe weather conditions. But that's where one of the advantages of being a defense contractor and developing tech for a harsh environment and different challenging environments came into play here, and we're able to deploy these trucks safely and effectively to maintain business continuity and safety. Another location we're deploying, we're always in the winter states, that's why I live in Florida, but we're up in, this is actually not in a state, this is actually in Canada. We deployed last year in a logging operation in northern Quebec in a pilot deployment, and things went really well there. The trucks were loaded. They load these trucks up to 140,000 pounds, which is huge. So most trucks running on the road are about 80,000 pounds. The sugar beet trucks they're running about 99,000 pounds, so this was kind of cool. We also have a deployment underway currently, running between Columbus, Ohio and Indianapolis, Indiana. We're running on the I-70 corridor. We're running in collaboration with a logistics company called Ease Logistics and Indiana and Ohio DOTs. And so the objective of the program is to evaluate the readiness of this sort of technology in a logistics operation, hauling 53-foot dry vans to different VIP clients. And lastly, I have a video on this one, so I'll just kind of let that run, but we did a deployment with Motorsports Logistics, and we just recently did that. I think it was in June or July, where we hauled all the NASCAR wheels and tires from Charlotte to the Indianapolis Motor Speedway for the Brickyard 400, which was a very cool opportunity to hang out on the track and meet all the race car drivers and whatnot. But can we go ahead and run that video real quick? Just kind of shows a little bit of tech integrated when we got to the facility to pick up the tires and wheels. Driving into the Indianapolis Motor Speedway. Yeah, so we are involved in a lot of different deployments, and what really is an enabler for us to be in so many different industries is the way that we do deploy with the tech and how we leverage the human decision maker and the lead vehicle to work around the different environments. And obviously we work very closely with the roadway authorities and DOTs in these locations. But it just kind of shows you what is possible and how our clients are seeing the value in the technology to enable us to put these vehicles on the road, and a lot more excitement to come. So thank you guys.
Okay, well, thank you very much, Maynard, for that great presentation. Now we'd like to ask Kevin Siegel, again from Kodiak Robotics, and then we'll have plenty of time for questions and answers after this. So, Kevin, great to see you again.
Thank you, Denver. All right, so as I mentioned yesterday, my name's Kevin Siegel, Head of Business Development for Kodiak. I've been with the company a little over 4 years, and prior to joining, I worked as a freight broker for about a decade. Working in freight, I saw the challenges the industry was facing from a driver availability, so driver shortage, visibility from track and trace perspective, poor service levels, and I knew there had to be a better way. I kind of saw the writing on the wall with autonomy, and I knew that was the future. So in 2021, I made the leap over to Kodiak, and it's been very interesting watching the evolution, because when I first started with the company, I'm reaching out and having conversations with leaders of these fleets. And as you guys know, trucking is a very old school industry. If it's not broke, don't fix it type of thing. So a lot of the folks I was speaking with, they would say, hey, Kevin, this sounds like something, out of Star Trek or the Jetsons. I'm retiring in a few years. This isn't going to be something that we see in my lifetime. Well, now with the prevalence of robo-taxis, with the Waymo and Tesla deployments, I guess a lot of the general public that doesn't have daily exposure to autonomy is now getting it. So that those same folks that I spoke to years ago are now reaching out to me saying, hey, I visited my daughter at college last weekend at the University of Texas down in Austin. We rode in a Waymo, and I know the technology's here. We want it in our supply chain. How can we start working together? So it's just been very cool kind of seeing the evolution of autonomy and how it's taking place. The trucking market is facing existential challenges and would benefit greatly from autonomy. In 2023, there was a 70% driver turnover for large truckload fleets, and as of last year, it's anticipated that over 1 million drivers will be needed over the next decade, both of which bring with them safety risks, rising costs, and inefficiencies. Tremendous progress has been made in recent years with autonomy, with driverless deployments always seeming to be coming soon. Well, for Kodiak, the future is here now. We've deployed our technology with customers and are generating driverless revenue today. Most people think autonomy develops in a slow, gradual progression, with many companies claiming to be close to going driverless. Oh, sorry about that. And in truth, full autonomy is binary. You're either driverless or you're not, and Kodiak is, I think, the only company that has an actual driverless product deployed today. Let's turn to the critical issue of safety. Safety is the foundation of everything we do and has been our focus since day one. Like I mentioned yesterday, we utilize what we believe to be industry best practices to formulate our safety case, and have built an evidence-backed case for why our technology is safe to deploy. Safety is not only a moral imperative, but is paramount for both public and customer acceptance. We also firmly believe that safety is a team sport, and have partnered with state and federal regulators, law enforcement, and other industry partners to ensure that not only our vehicles, but AVs industry-wide are fundamentally safe to deploy. What's Kodiak's origin story? So we were founded in 2018 by Don Burnett. Don was one of the first 10 employees at Google's self-driving car project, which evolved into what is now Waymo. Upon our founding, our focus was domestic over-the-road trucking. That shifted in a sense in Q4 of 2022. We were awarded a contract from the Department of Defense, and as part of that, we had to build out our off-road capabilities in unstructured environments. Our tech stack adapted extremely well to these conditions. So at that point, we said, are there any domestic applications here within the US that we could take a look at with our tech? And that's when we got linked up with Atlas. I'll talk a little bit more about that here in the coming slides. And then the exciting thing that we have going on now is we're on, as I mentioned again yesterday, on our path to becoming a publicly traded company. That should be completed here, I think, in 9 or 10 days. So it's certainly an exciting time to be with Kodiak. Achieving our milestones has led to real-world impact. To date, we've delivered over 7,300 commercial loads and driven roughly 3 million miles. Paid driverless operations, we've driven 3,000 hours. We view paid driverless hours as a key metric when assessing the progress and success of an autonomy developer, regardless of the use case, because it provides a unit of measure for delivering value to a customer. As an example, you could have 24 trucks operating 1 hour per day, or one truck operating 24 hours per day. Both provide the same value to a customer. And now that we've got a driverless, now that our driverless tech is deployed, we view paid driverless hours as the most meaningful metric going forward. We've built an extensive autonomous freight network of over 23,000 miles across the southern half of the US, where we haul freight for our growing customer base, including J.B. Hunt, the largest intermodal carrier in the country, Werner, one of the largest dry van carriers, and C.R. England, one of the largest refrigerated carriers, amongst many others. The lanes in red are the ones that we have driven and are operationally ready today. The ones in yellow are the ones we deliver freight on a daily basis. Texas, more specifically Dallas-Fort Worth, has become a national hub for autonomous trucking due to its freight-rich environment, strong infrastructure, and supportive regulatory environment. And then the lane that we're kind of most proud of and excited about is Dallas to Atlanta, which is 750 miles across multiple states. For a single, that's a 2-day transit, or you have to pay a premium for a team to get it there in one. This is the exact type of lane that we think autonomous trucks can deliver the most value for. At roughly a 15-hour, approximate transit time, we think the ability for autonomous trucks to essentially run 24/7 will greatly increase the efficient movement of goods and asset utilization.
In early 2024, we completed our first driverless delivery in the Permian Basin, a journey that began in 2018 with the vision of revolutionizing ground transportation with autonomous technology. Today, Atlas operates Kodiak driver-equipped robo-trucks, delivering sand daily. Once integrated with the Dune Express, this fleet is designed to create a fully automated supply chain that connects production to delivery with unmatched efficiency. Each robo-truck deployed drives our growth, delivering value for our partners while generating revenue. From vision to reality, the future of transportation is here. Kodiak, delivering today.
So taking a closer look at our partnership with Atlas Energy Solutions, Atlas is a publicly traded company servicing the oil and gas industry. We haul proppant, also known as frac sand, for them from mine to well site to support fracking operations. We initially started with a single trailer. We've since progressed to hauling both doubles and triples with a payload exceeding 100,000 pounds. On any given day in the Permian Basin, there are thousands of other actors on the road, from commercial trucks to passenger vehicles. Our trucks blend in with the normal flow of traffic to the point where the majority of folks don't even realize that they're sharing the road with an autonomous truck. If you know anything about the Permian Basin, it's basically in the middle of nowhere, Texas. Temperatures regularly exceed 100 degrees. The roads are, I mean, for lack of a better term, they're terrible, riddled with bumps and potholes, making driving conditions difficult for even the most seasoned operators. Combining those factors, hiring and retaining drivers is a constant issue for fleets that operate in the region. But at the same time, it creates sort of the perfect storm, so to speak, for why an application like this is ripe for autonomy. So as previously mentioned, we recently started generating driverless revenue from the work that we're doing with Atlas in the Permian Basin. We were the first two companies to publicly announce that driverless trucks have been integrated into commercial operations where the trucks are fully owned and operated by the fleet operator, Atlas. These trucks run day and night, 7 days a week, and we've already achieved over 3,000 hours of paid driverless operations. Subject to the terms of the master service agreement, we've secured Atlas's contractual commitment for the first order of 100 autonomous trucks, which is a pretty big deal for us. And we've got big plans together, and we're excited about Atlas's commitment to growing their deployment with us. Our autonomy solution is known as the Kodiak driver. We use the same tech stack across all the different applications that we service: on-road trucking, off-road industrial, and military defense. Any learnings from any of those three are kind of directly transferable and applicable to all, which is why our system is as mature and robust as it is. Our solution is both drivetrain and platform agnostic, so regardless of the propulsion system, whether it's internal combustion, battery electric, or hydrogen, our technology is compatible. And then the biggest differentiator between Kodiak and our competitors from a hardware perspective are our sensor pods mounted on both sides of the cab. They contain all the sensors, so camera, LiDAR, and radar. We've demonstrated that should any of the sensors go down for whatever reason in less than 10 minutes, so it's 4 bolts, 3 connecting cables, you pull that mirror pod off, a pre-calibrated mirror pod goes back on the truck, and you're up and rolling again. From the conversations that we've had with our fleet partners, aside from safety-related metrics, the most important thing they track is fleet uptime. So we think from a serviceability and scalability perspective, our solution will enable our partners to achieve maximum asset utilization. Piggybacking off of the last slide, our platform we're platform agnostic rather, so we've integrated into multiple Class 8 OEMs here in the States. All of our OTR trucks are Kenworth T680s. All of the trucks that we have for Atlas are Peterbilt 567s. We've done a Ford F-150 for the military, Textron, they're a defense OEM. We've done their unmanned ripsaw vehicle, and then different trailer configurations, whether it's intermodal containers, dry vans, refrigerated trailers, or hoppers like we're doing with Atlas. Our technology is capable of working with any of them. A question that inevitably comes up is, can these trucks operate legally on public roads? And the short answer is yes. So there are currently 24 states with AV legislation on the books. During Richard's presentation yesterday, he mentioned 25 The discrepancy there is with California specifically. They have autonomous vehicle legislation allowing robotaxi deployments, but not yet commercial trucks. So, I mean, we're hopeful and expecting something to be passed with California in the next 6 months, give or take. But as of today, there are currently 24 states. Most importantly, our existing routes are where you see the strongest concentration of permissive regulation. And then, as I kind of touched on yesterday, the current administration seems to be leaning in to autonomous vehicles more so than previous ones. So we're hopeful at some point in the next couple of years that a federal framework will be passed, unlocking the additional states. So I've talked about the technology. How does the business model work? So as an example, let's say somebody wants 100 autonomous trucks. You give Kodiak the base power unit. At that point, we install all the technology required for the truck to operate autonomously. So hardware, software, sensors, and compute. That's all installed free of charge. The trucks are then returned to our partner to operate in their network as they see fit. Our driver as a service subscription model for over-the-road trucking, we charge a per mile subscription fee with a minimum number of annually billed miles. And then for off-road applications like we're doing with Atlas, you can't really charge per mile because the trucks go much slower, like 15 to 20 miles an hour typically. So what we do there is we charge a licensing fee per month. Important to note that the way that it's structured is pay as you go, which mirrors kind of how fleets currently pay their drivers. There's no upfront CapEx expenditure required to get into autonomous vehicles. The age of autonomy is upon us, and Kodiak is in the driver's seat, and we're excited to help push the industry forward.
Oh, thank you very much, Kevin, for that great presentation. So we have ample time for questions now. Jody has a mic, and I'll join here in just a second with another one. So let's start the questions.
Yeah, thank you. A great presentation. Maynard, on the platooning side, what type of regulatory barriers are you guys finding? And then is there some type of model legislation out there that you believe provides a good venue for you guys to operate in and still provides that regulatory oversight that's healthy?
Yeah, so the regulatory environment for platooning is very similar to the autonomous vehicle, autonomous truck folks. You do have some different statutes, like for example, statute of follow too closely, where you have a minimum distance that the trucks need to follow, or when they're on the highway environments and that sort of thing. But for the most part, it's pretty similar. Platooning sort of falls into the gray area, and what I mean by that is, the SAE level 2 SAE automation level classifications don't really align to platooning. So there's some flexibility there, and an example would be when we first started putting the autonomous truck-mounted attenuator vehicles on the road. I had classified the follower as level 4 automation because the truck can be operated with nobody in the cab, and that's fine. Everybody was on board with that. However, when we started running in California, as Kevin indicated, the legislation in California does not permit driverless vehicle operation of vehicles over 10,000 pounds at SAE level 3 automation or higher. So Caltrans asked us if we could walk back the automation level to SAE level 2 because they wanted to deploy their vehicle with nobody in it, which to me is fine if they're accepting of that. And the justification for that is they consider the vehicle to be remote controlled since the navigation data comes from the leader to the follower. So there's a flexibility there, and that's one of the ways we work around it. another way, or I shouldn't say work around, I should say work within, but another way that we sort of work within the regulatory policy is we mainly support for tractor trailers, for example, supply chain. We're doing short haul, so we're doing 24/7 supply chain routes, and most of these are 200-300 miles or so. We try to maintain within a single state, for example, North Dakota, where there's less regulatory complexity than going state to state. And however, with the sugar beets, they haul sugar beets in North Dakota. They also haul sugar beets from the Minnesota side. So I'll give you an example there. The legislation between North Dakota and Minnesota is fairly similar. And the state legislation, the routes that we want to run the sugar beets on, which are 2-lane county roads, do not fall within their jurisdiction. So in North Dakota, they gave us a waiver as long as the district representatives in the Wahpeton area were okay with us deploying the driverless vehicles on the roadways. North Dakota would permit us to operate the vehicles with our approved platooning plan. So on the Minnesota side, we were not able to get the waiver on that side yet. It's something that we're working on. But so what we do for some of the deployment is if we have to haul the sugar beets from the Minnesota side, our system operators will operate in auto platooning mode up to the border of Minnesota, flip it into idle mode, so they're basically manually driving but also collecting data, load the trucks, come back, and when they go across the border into North Dakota again, they go back into auto platooning mode. So that's just another example of how we work within the boundaries, and we crafted our ODD, our operational design domain, around those sort of things to put our vehicles on the roadway.
It was clarified yesterday that with the autonomous trucks, we don't need any serious infrastructure upgrades. But now when we introduce platooning, we are going beyond autonomous. We are looking at more like CAVs because we expect communication between the lead vehicle and then the follower. So I want to know if we are deploying platooning, would we also need any infrastructure upgrades, or they could use the normal roads that the conventional vehicles are using?
So for platooning, the advantage that we have is that we do have a human-driven lead truck that guides, sort of human-guided autonomy, if you will, that guides the driverless follower. So we have our map data being pretty much written in real time with the driver. The navigation systems that we use, we have a multi-layered or multimodal navigation system. So we use a combination of RTK, or I should say dynamic RTK GPS. Dynamic meaning RTK, usually in the ag space, has a stationary base station, like when you're running combines or tractors and that sort of thing. With our deployment, the base station actually travels with the convoy itself. So it enables us to get very high accuracy, centimeter level accuracy. So that's one layer of the navigation system. The second layer of the navigation system is we use an inertial nav system. So we use a sensor called an IMU. This enables us to operate when we get into a GPS denied or degraded environment. So if you can imagine going under an overpass, or with the logging industry being in an environment with heavy overhead canopy, and then that will only get you so far. These IMU sensors, they all have a factor of drift where they'll eventually need some sort of a correction, and you kind of have to, you can't use the $100,000 IMU sensor that we would put in a military aircraft because it just wouldn't be economically feasible in the commercial space. So you have to pick something that's good enough, and then the third layer of our navigation system that enhances the ability to drive in a GPS-degraded environment or denied environment is our optical navigation system, where we use a type of terrain mapping, not necessarily looking at lane lines, but lane lines, road edges, the environment around us to sort of match what the lead vehicle is seeing and the follower vehicle is seeing. So they're coordinated optical navigation with that system. So in general, we do not envision and have not previously needed any kind of modifications to the infrastructure to enable our deployments. And it's simply a nature of the technology that we're deploying as sort of a leading edge where we make use of available technologies today, and also the added benefit of having a human in the loop who can navigate in complex roadway environments.
Maynard, Raj here. Once the regulatory situation allows you guys to operate, anywhere and everywhere without the driver, so it's driver out, are there any advantages still to having the platooning?
Yeah, for sure. I'm with a lot of giants here who have been in the trucking industry for a long time, and there are use cases for the technology to be deployed completely autonomous or independently autonomous truck, as well as also with platooning. So, like in Kevin's example with the frac sand, in my examples with sugar beets and other ag products. We're running supply chain stuff where our clients can use as many truckloads as possible, right? And where we're running in rural environments that, as a side note, are historically overlooked when it comes to these kinds of technologies. These rural locations already have low population density, right? So they need a way, our clients need a way of maintaining business continuity when they are impacted by driver shortages. So by being able to pair the driverless truck with the human-driven truck, one leader, one follower, as well as also the legislation in the area permits up to 3 driverless followers, so 1 leader and 3 vehicles. There's certainly a play in that environment where platooning absolutely makes sense, where they're moving a lot of product. And if you can imagine the challenge of deploying a single human-driven leader with multiple followers and trying to enter the interstate, it just wouldn't happen. But that's all part of the deployment model. How you would deploy a single leader with multiple followers is a part of how we craft the deployments. Where, for example, you would have the trucks lined up along the roadways, then turn the system in automated mode and move the product from point A to point B, which is the heavy challenge for our clients, is getting that product moved, and then they have people at the endpoints that can take over the manual driving. So there's a lot of advantages there. So yeah, it's a sizable market.
So with the platooning, does this count as a doubles, triples endorsement driver that needs to be qualified, and do they get like LCV pay in terms of how they're operating?
Well, I'm going to have to defer to my logistics folks. I'm not that deep into the understanding of that. But how I can talk to that is the operators that we train to run the systems. We automate the trucks and we deliver the trucks to our clients, and they run the trucks. And everybody that's running is a very seasoned CDL. They bring a lot of experience to the table. And we have a very comprehensive training program, as I mentioned, where we get these guys familiar with the technology, and they transform from simply a CDL truck driver to a system operator. And it's really amazing how well they use the technology and adapt it into how they would normally run trucks. For example, how they change lanes and how they merge and different things like that. It leverages their experience as a CDL. So we offer them the tool, and then they make it their own to deploy in the correct ways. And then, as I mentioned, we work very closely with the different roadway authorities, Highway Patrol, DOTs, and different agencies to ensure compliance to the regulations. But yeah, I'd have to defer to one of my smart guys for that one.
Thank you.
I have a question for Kevin and Kodiak. What restrictions do you see for your system to be running on North Dakota highways within the next year, and even on secondary roads other than interstate and smaller roads? And if there are any restrictions, maybe there isn't, but what can we as researchers and state agencies do to help eliminate those restrictions so that by the time Denver does the conference next year in 2026, we can show some examples of trucks actually running in North Dakota autonomously?
As far as restrictions on roads in North Dakota, I mean, public roads at least, I would say kind of the same restrictions that we're seeing in other states as far as just we're still in the process of validating our safety case, which is why we still have a safety driver in the cab. We're planning to pull the driver out on select routes the second half of next year. Now, as far as other conditions like snow and stuff, I would say if there was a compelling enough use case in off-road environments, that's nothing that couldn't be optimized for from an engineering perspective today. I know, a lot of the other developers have issues handling dust and like sandstorms. We regularly see those in the Permian Basin, and we're able to solve that problem. So I would think if there's a compelling enough use case with enough scale, we could absolutely tackle it in the near term. And then as far as public roads, once we're comfortable enough with our safety case to pull the driver out, I don't see why it couldn't operate on public roads in North Dakota the same as it could in Texas.
Okay, while we're waiting on other questions from the audience, you both talked about different applications, or some cases the same applications and markets that you have right now. Are there any additional potential use cases that you're thinking about and looking at that you can discuss with us now, and maybe start with Kevin?
I would say kind of the main verticals that we're currently exploring are mining and mineral transport, oil and gas, like we're doing with Atlas, and then forestry or logging. From the conversations we've seen, those seem to be the best fit for the tech from a ODD, operational design domain, geographic perspective. Those aren't halfway across the world. There's a lot of them domestically that we could tackle. So I would say those are the primary use cases that we're having ongoing conversations with potential partners on.
Yeah, I tend to agree with Kevin. We're all looking at the same industries and where we can, maximize our own ROIs on developing the tech and how we can solve the challenges for different industries. I've been fortunate in my career that I've had the opportunity to work in a lot of different spaces. The defense space is certainly a cool spot to be in, and then transitioning into highway maintenance, agriculture, mining, and different locations. There's a lot of ways that we can adapt the tech and really show unique value. We look at the Class 8 tractor trailers as one area, but we also have some other industries and other adaptations on the tech on different vehicles where we can continue to adapt to solve challenges for these industries as well as some others.
I just had a question with the platooning. You were talking about the real-time mapping from the lead truck to the follower truck. What allowable deviation does that follower truck have from that mapping and the first truck?
Yeah, so we're pushing data out of the lead truck at about 10 times a second, right? The vehicle, the follower vehicle, has the ability to sense its environment as well. So we bolt sensors on there for obstacle detection, optical nav, obviously, and different things. They can also space the vehicles out. Normally in the highway, they like to run the trucks at a gap spacing of about 100 feet or so. And in some cases, we need to be 300 feet or 500 feet, depending on the state and like I said, the follow too closely statutes. But when we're in platooning mode, the platooning legislation does, in some states, address that and permit us to be closer. The map data that we're getting is more than sufficient to provide the path and the route for the vehicle to follow. And then, I talk about gap, and I know everybody wants to know, well, what happens if a vehicle gets in the gap? So we see this quite often, even at 100 feet. When we did that NASCAR haul, we had a tractor trailer. We were spaced out I think we were at about 100, 125 feet or so, and we had a tractor trailer that was in the adjacent lane blow a tire, and they just zipped right into the gap vehicle and pulled off onto the shoulder, which I thought was really pretty amazing. And what happens is the follower truck works as sort of an adaptive cruise control. So imagine you have a gap distance set for the space between the lead and the follow. You get an intrusion vehicle in there, and the follower vehicle will then slow itself down to back up off the intrusion vehicle to whatever the gap setting was. Okay, so then what happens? Another person gets into that gap, and you could potentially stack up vehicles within the gap of the truck. I mean, we can run up to 1,600 feet, I think, is a hard stop that we put on there, which is somewhat arbitrary, but you really don't want to. Like, the further the trucks get spaced out, the more challenges you have with your deployment, as I'm sure you can imagine. But where we address that challenge is with the driver training, and that's where we work very closely with the CDLs that operate the system. And what they're trained to do is to slow down just a little bit, because the reason people are getting in the gap of the trucks is either they're trying to pass the trucks or they're trying to get into an exit ramp or something of that nature. So that's a really pretty cool example of how we work together with the operators and the drivers and address some of these roadway challenges.
For the truck platooning, how does the follow truck know when the lead truck either one swerves around a tire and needs to swerve as well, or if the lead driver makes a mistake and exits the lane, does it always follow what the lead driver does exactly, or does it make its own decision and say, hey, that wasn't correct what the lead driver did, I'm going to do my own thing?
Yeah, I mean, you absolutely hit on something. Again, with the NASCAR haul, there was a tire that was right in the middle of the road. I was in a chase car in a rental car, which I always get the full insurance on just in case. But either way, they did actually swerve around the tire, and the follower truck swerved as well. I mean, when you think 10 times a second, we're running that real-time map data. I say real-time, but it's near real-time. But either way, the truck will exactly follow that path. And the next question that usually comes in, which has been asked a lot of different ways, but it's, if the lead vehicle driver drives off the road, will the follower follow? And the answer to that question is we do have geo-fencing that's integrated into the vehicle. And so if we see, if the follower vehicle sees something that looks unusual, driving off the road, for example, it can make its own decision to stop. Now, if there's a stationary obstacle in the path, which does quite often happen on the highway maintenance trucks, we're running the TMAs. We do not have the truck autonomously navigate around a stationary obstacle. Let's say there was an obstacle that stopped between the leader and follower. In that scenario, the vehicle is just going to stop. We're not going to navigate around it, and that's the same with the tractor trailers as well. So we can pull over to the side of the road, or we can do different things, and it all kind of depends on the state and the client and what the regulatory and stakeholder agencies want to do in those different scenarios.
This one's for platooning too. So I kind of assume that the second follower vehicle, there's an ability to get some fuel savings. Is there like a sweet spot that the gap should be to get a good fuel savings?
Well, so our primary objective with platooning, and I understand the question, in the early days with platooning, the objective was fuel economy and really maximizing that. But our objective here is addressing driver shortage, right? We operate in environments that are rural, low population density, and they do not have enough people. Young people don't want to drive the trucks. They do not have enough people to maintain their supply chain activity. And you're addressing growing global populations, food security, national security. They really are. An example would be, I think the average driver age, and somebody can correct me if I'm wrong, but I believe it's about 60 years old. Well, in the locations where we're operating, the average driver age is 58. In the environments where we're operating, average driver age is about 60. So the drivers are getting much older, and the pool of available drivers is difficult. The clients that we work with spend a lot of money on trying to recruit drivers. We're also seeing where they sort of, I hate to say water down the requirements, but in some cases you can even waive CDL driver's license requirements to operate the vehicles, for example, in peak harvest season, or they'll go south of the border and bring in drivers that can come up, basically just fill the seat and operate the vehicles, which they're not always the most qualified drivers. And what our clients are seeing is a real solution in platooning using technology that's available today so that they can maintain their continuity. And when they're short a few drivers, they just flip the system on and they pair the human-driven vehicle with the driverless follower, and they maintain their haul capacity in that regard. So that's really our challenge. And our deployment model being short haul and very variable speed in different, not urban, but close to an urban environment, we really wouldn't see an ability to maximize any kind of fuel economies. But I do believe about 126 feet was the sweet spot for fuel economy.
All right, so from the agricultural side, is there any autonomous vehicle handling, like harvesting? Moreover, how do you handle unstructured environments, especially on the farm?
How do we handle, what was it?
Unstructured environments where there is no like structured road and stuff.
Unstructured, gotcha. Yeah, I mean, again, we have a human driving the lead vehicle, which guides the vehicle forward, and we have a multi-layered navigation system that uses a combination of, GPS, RTK, right, inertial nav, and the optical, and that's how we address that in an unstructured environment.
Okay, maybe a quick follow-up on that same question. At the Autonomous Nation conference last week, the discussion was about totally autonomous agricultural supply chain, all the way from production, harvesting, etc., storage, then on to the first delivery point, which would be off the farm, let's say a satellite elevator or a subterminal. And the discussion around that was, will that function the way that farmers do now, where farmers own a tractor and semi-trailer, they drive it around the farm, which is a very unstructured environment, and then they drive it off on the road. So you have a combined off-road and on-road autonomy. So the question is, what is your vision for that happening, which really needs to happen, and what sort of time frame would you might be looking for?
Yeah, so that's a good point. Like, I do not come from the ag space, so there was a learning curve that I had to come up to speed with, and thankfully there's an organization in North Dakota called Grand Farm. We collaborated on what a deployment might look like, and we had to work together to figure it out because we quite honestly had no idea. And so I came out and I spent a lot of time with the farmers and the industry and looking at how they run trucks. And the initial thought was, okay, the farmers own trucks. They run alongside the combine, and the combine loads the trucks. In some cases, they are paired. You'll see two trucks periodically. Or sometimes the trucks are waiting on the side of the road, and you have these. Then the combine is loading these carts, and then the cart loads the trucks. So, we looked at that. And the challenge that was there is that, the farmer-owned trucks was a variety of, good, bad, and ugly. All different kinds of makes and models, all different kinds of conditions. I mean, I was like, whoo, okay. And then on top of that, you throw in that you're driving on a field that can be very slushy and muddy when you're trying to harvest these beets. And it was just like, automation likes consistency, right? So I was a little disappointed at first, and then I noticed this one group of trucks going by, and they were all brand new, and they were running on the road, and it looked really cool. And I was like, "What is that guy doing?" Right? So we started following those trucks and realized, well, there's two parts to the harvest. There's the part where the the truck pulls the beets from the ground and brings it to these satellite storage locations, like the sugar beet pile or the grain elevator or whatever. And then there's the remainder of the season where the trucks are running from these storage locations, feeding the factory, making the product. And I was like, that's where we need to be. And those supply chains are running 24/7, and they have the same sort of challenge. So that was our sweet spot. Where I envision us potentially one day going to be on the field, there's a lot of people, thank God, working on the autonomous space, and there are some great companies out there that are working those hard problems. You see these companies with autonomous carts. I mean, John Deere certainly with the combines and different vehicles that are made for that environment. And what I would see is a collaboration between companies and technologies where you will eventually have a completely automated supply chain that will go from the automated tractor, combine, on-road trucking into the facility and the unload. And yeah, I could totally see that. And to be quite honest, to address the quickly growing global population, we will need to integrate more automation just to be able to keep up with the food security that's required. So, timeline, a couple years.
Kevin? I like the timeline.
Our trucks are already operating in off-road environments like what we're doing with Atlas, then also for military and defense applications. So to anyone in the audience, if that's the specific use case that you'd be looking at for autonomous vehicles, I'd say let's have a conversation and see what we're able to do.
Outstanding. Okay, we have time for one more question before lunch.
Kevin, question a little more for you. So as you're running the routes that you've run now, when the truck gets to destination, does it park itself in a door, or that is up to a team to unload, or how are you addressing that? Is it just point A to point B, or is it to an unload station?
For all the pilots that we're doing over the road on public roads, we still have a safety driver in the cab. So that safety driver is able to bump dock, so to speak, and to back into a door. We do have other pilots that we're doing where it's set up in kind of the operational model that we may be using in certain instances where we utilize a transfer hub. So one of the lanes, Dallas to Atlanta, we partnered with JB Hunt on it. JB Hunt is doing the first and final mile piece. So they bring the initial load from the shipper location in South Carolina to our Pilot Flying J transfer hub in Villa Rica, Georgia. At that point, they drop the trailer. Autonomous truck handles the entire basically highway segment between Dallas and Atlanta, drops it at our terminal in Lancaster, Texas, and then a local driver from JB Hunt completes the delivery. So there's no one-size-fits-all solution. It's really on a case-by-case and location by location, specific.
Thank you.
Okay, well, thank you very much, Maynard and Kevin, for that great panel.